This is SpaceTime Series 29, Episode 73, for broadcast on the 19th of June 2026. Coming up on SpaceTime, the earliest known flickering quasar, Europe's ExoMars to target a vast clay bed in its search for life on the red planet, and understanding neutron star mergers. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered the earliest known flickering quasar, dating back to a time when the universe was just 850 million years old. Their findings, reported in the journal Nature Astronomy, show this voracious supermassive black hole was already surprisingly mature. A supermassive black hole lies at the heart of every galaxy, including our own Milky Way. As a black hole feeds, it pulls material into an accretion disk, a whirlpool of high-temperature gas and dust. As this material piles up and falls onto the black hole, it lights up, radiating huge amounts of energy. And the most energetic supermassive black holes are known as quasars. They can be some of the most active and luminous objects in the universe, clearly visible from across the other side of the cosmos. The pattern of light coming from a quasar can give astronomers clues about how supermassive black holes shape the galaxies around them. Now, astronomers have detected a quasar flickering in the early universe. One of the study's authors, Jean Leung from the Carverley Institute for Astrophysics and Space Research, says although there have been lots of quasars found in the cosmic dawn, this is the first time astronomers have actually seen one flickering. And that's important because the quasar's flicker allowed Leung and colleagues to determine that surprisingly this ancient quasar's whirlpool of gas and dust resembled a flat pancake similar in shape to that of more modern-day quasars. The findings add to a long-standing mystery in cosmology. Why do supermassive black holes exist so early in the universe's history? Physicists have always assumed that a flat accretion disk reflects a relatively mature black hole, one that's already calm and stable. On the other hand, black holes that are just starting to form, like those often seen in the early universe, should be more unsettled systems, with accretion disks that appear to be more fluffy and chaotic. So the flat accretion disk around this very early quasar heightens the mystery of how supermassive black holes can grow and mature in relatively short amounts of cosmic time. It suggests that all the messy, very rapid growth phases that astronomers expect all black holes to go through at some point must happen very early on in their evolution, long before they're seen as bright luminous quasars. A supermassive black hole can be billions of times more massive than the Sun. These gravitational giants are the central engines of most galaxies, helping to regulate the galaxy star formation and growth. Without supermassive black holes, no galaxy would look the way it does today. Now, it was long assumed that it should take more than 1 billion years for the first galaxies to settle and mature. So scientists didn't expect to see supermassive black holes in the very early universe. But observations since the early 2000s have shown otherwise. In fact, scientists have now spotted well over 200 supermassive black holes in the universe's first billion years of existence. These objects were detected because of their extremely active quasars, giving off enormous blasts of radiation that could be seen on Earth some 13 billion light-years away. These earliest quasars were observed as pinpricks of light, signaling the existence of a supermassive black hole in very ancient times. But from these bright and distant dots, scientists aren't able to tell much more about the black holes or their cosmic dawn environments. To do that, they need to catch a quasar's flicker. Owen says people have known that quasars in the nearby universe can flicker. The flickering comes from fluctuations in the way the gas is being fed into the black hole. And how a quasar flickers tells astronomers about the structure of the black hole's accretion disk and the rate at which it's consuming material. But the further back in space and time the object is, the more distorted its light appears. This effect is due to the expansion of the universe, which effectively stretches or redshifts light to redder, longer wavelengths. And the same stretching also occurs in time. Any flicker that naturally occurs over several weeks, for instance, would appear stretched out, flickering only every few months when seen from billions of light years away. So to spot a flickering quasar from the cosmic dawn, the authors needed to observe the distant universe at redder wavelengths, and specifically within the infrared spectrum, and over long timescales of many years. The Wynne and colleagues ultimately found a flicker in a quasar in data collected by NASA's Near-Earth Object Wide Field Infrared Survey Explorer, or NEOWISE mission, a space-based infrared telescope that scanned the entire sky over a total of 14 years. Based on the reprocessed data, the authors unearthed a signal from just 850 million years after the Big Bang, which they've now confirmed as the earliest known flickering quasar. Yuan says the observed quasar is flickering randomly over a 14-year period, much like a candle flame flickers without a fixed pattern. They estimate the quasar is as bright as 12 trillion suns, and it's flickering by about 20%. That means it's fluctuating up and down by a brightness of about 2 trillion suns. The authors also tracked how the quasar's light flickered over several different wavelengths. The wavelength of light reflects a certain temperature of material that's being emitted in the light. The closer the material is to the black hole, the hotter it is. So astronomers can use the wavelengths of light to map the shape and structure of the material within the accretion disk as it goes around the black hole. The authors analysed the quasar's flicker to determine the shape of the accretion disk surrounding the central supermassive black hole, finding it to be surprisingly thin and flat, a structure that astronomers mostly only see around nearby older black holes, ones that have had a lot of time to settle down and mature. So this provides direct evidence that the same feeding process and structures observed in the nearby universe were already in place at very early times, despite very different cosmic environments. It means that something must have happened even earlier in the universe's history that led to these systems looking so mature. This is SpaceTime. Still to come, the European Space Agency selects a vast clay bed known as the Oxyoplanum as the best place on the red planet to search for signs of life, and scientists have used deep learning neural networks to better understand the violent events associated with the merger of neutron stars. All that and more still to come on SpaceTime. The European Space Agency has selected a vast clay bed called Oxyoplanum as the best place on the red planet to go searching for signs of life. A new study reported in the journal Icarus has determined this area, which is thought to have once been covered by a vast ocean, have massive clay deposits that extend far beyond previous estimates. Clay minerals require liquid water to form, and they hold clues from a time when the red planet was a warmer, wetter world, far more hospitable to the formation of life. The new findings point to the presence of large amounts of water shaping in the region, possibly across the entire planet. The 6-wheeled ExoMars rover will investigate whether these clay-rich sediments have traces of past life in them, and it will also learn more about the water environment in which these clays were formed. As Oxyoplanum lies in an open basin, it's possible the clay deposits there were shaped by an extensive body of water reaching several kilometres in depth some 4 billion years ago. Mind you, another scenario could simply be that large amounts of water flooded vast plains from ancient groundwater reserves. The study found that the clay deposits at the proposed landing site stretch for as much as 300 kilometres in any direction. ExoMars project scientist George Vargo says the mission will target the oldest deposits in the sequence, and that makes the potential implications for geology and early climate on Mars very relevant for the mission's search for life. See, understanding the nature and origin of these clay minerals will be essential for reconstructing the planet's climate and assessing habitability. Oxyoplanum's clays formed first about 4 billion years ago, predating those of other locations on the clay pan. To reach their conclusions, the authors used the Omega instrument on the European Space Agency's Mars Express orbiter and the XRISM instrument on NASA's Mars Reconnaissance orbiter. This allowed them to examine the mineralogy and reconstruct the rock layering between Oxyoplanum and a more distant location called Marworth Valleys. Their analysis revealed that both sites have similar mineral layers. At the boundary between the two main clay-bearing units, the authors identified a paleosurface, a remnant of an ancient exposed surface that was heavily cratered and later covered by younger deposits. This paleosurface marks a pause in sedimentation, followed by a shift in water chemistry and mineralogy across both sites. These results align with studies suggesting an intermittently wet climate in the early Martian environment. Guided by this finding, the rover will try and confirm the orbiter's results from the surface. The ExoMars rover has a unique suite of instruments for carrying out its mission. These include cameras, spectrometers, a ground-penetrating radar, and an analytical laboratory designed to investigate the landscape's geological context and examine samples collected by a drill able to reach some 2 meters below the Martian surface. And that's important because any evidence of past or present life on Mars on or near the surface would have been irradiated away and destroyed long ago. But deep down, below a protective layer of regolith, that evidence may still survive. In fact, it may be our best chance yet of finding out if life ever existed on the Red Planet. This report from ESA TV.
Has life ever existed on Mars? And could life have survived and evolved for billions of years? In their insatiable quest to find life in other parts of the universe, humans have often looked at the Red Planet. After all, Mars is a rocky planet like Earth, orbiting the Sun and at a distance where water could have been present in the past. We are unlikely to find Martians on Mars, but tiny traces of ancient rivers, lakes or even oceans could give us fresh clues about whether some sort of life could have developed. Finding these fresh clues is exactly what the ExoMars mission is all about. It aims at sending a rover to the Red Planet to explore and retrieve samples from its soil. After many years of testing and fine-tuning, the rover was due to be launched into space in 2022. But events on Earth thwarted these plans.
The war in Ukraine has had a massive impact on our work.
Pietro is the ExoMars rover manager for ESA. He's come to oversee some tests in Turin, where the rover and its Earth twin are housed.
We were ready to go to the launch campaign for ExoMars, and we had all of a sudden to stop and to reconsider our plans.
So I suppose it's been quite tough for the teams as well.
Yes, for the team it's been very, very difficult to digest this decision, because they've been working very hard in the last years, and it was indeed difficult also from a human perspective. But of course they understand the political implications, so they managed to let's say reset and to start working on a new enterprise, which is the ExoMars rover in Franklin mission.
So what are the new plans really for ExoMars?
The new plans are to build a new lander, this time an European lander. The previous one was built also with the help of European industry, but was mainly Russian made. This time we will be building it completely in Europe, with some contribution from NASA that we might need for the propulsion system.
So we'll have a new European lander, we'll have a refurbished rover. What's the timeline? When can we hope that the rover will be launched?
We are now targeting a new launch opportunity in October 2028. Cannot be earlier because we need time to build, to redesign and build and requalify the lander. So there is a certain time that is needed for that. We don't want to go beyond this date, because then the environmental conditions on Mars are not favorable for the mission that we want to do with the rover.
Despite these turbulent times, preparatory activities for a trip to Mars never really stopped, and tests are picking up again in this building here. That's the home of Amalia, the Earth twin of a real rover.
Amalia lives by the Mars Yard, a large hangar filled with 140 tons of soil that simulates the conditions the rover will encounter on Mars. Amalia is a replica of a real rover. It enables engineers to rehearse various scenarios that the real rover might encounter in a harsh Martian environment, helping them to make key decisions. Last year, we came to this very same spot to film some peculiar moves called wheel walking, a unique locomotion system enabling the rover to overcome difficult terrains. But this year, it's a drilling test that keeps the team busy. An exciting time for all of them after working hard to reshape the ExoMars mission.
So Andrea, we met about a year ago during the wheel walking tests, and of course a lot has happened since then. So how did your team handle the events on Earth?
Well, it was of course tough. So we were on the climax. We were at the end of a big test campaign, both on the GTM, on the Amalia side, and on the protoflight model for the preparation for the transfer to the launch site in Baikonur. So after the climax, there was, of course, the team faced some difficulty to accept the change of paradigm of the new mission. But then we took it as an opportunity. The team has been renewed. We have a lot of newcomers with a big, let's say, positive spirit, and we are facing again this as a new challenge that we are used to manage.
Okay, and so what is going to happen then in the next few months, few years? The mission is changing slightly, so what are your plans?
The rover was accepted and qualified for the 2022 scenario. We are now facing a new mission scenario, and the idea is to upgrade the rover in order to be capable to survive what is called the global dust storm season, so a bad season on Mars. With a lot of dust suspended. So we are going to implement all the means that are necessary to survive such environment, like tiltable solar arrays, larger part of RHUs, so nuclear power to keep the rover warm. Of course, we need the time to build all what is necessary to build around the rover. And that is probably going to take 4-6 years, and that is the time frame we have to upgrade the rover and to make it more attracting for the engineering and scientific community.
So I have one very simple last question is, of course, we've got the rover up there and it's hanging from the ceiling. So I know there's something about gravity on Mars that's involved.
So what we need to simulate on Earth is the same gravity as on Mars, that is 1/3. So we created a ground support equipment that is the rover offloading device that basically pulls the rover of 2/3 of its weight. And through that we were capable to really demonstrate the functionalities of mobility and drilling in a representative environment.
The next day, the drilling test is finally ready to begin.
Okay, Tazi Rock, we are ready to send the commands to collect the sample at 1.7 meter depth. I will give it on my mark, so 3, 2, 1, mark.
The Earth Twin rover will try and drill into a clay stone at a depth of 1.7 meters, much deeper than anything other rovers have ever attempted on Mars. Such a depth will offer access, it is hoped, to organic material from 4 billion years ago, when conditions on the surface of Mars were more like those on the infant Earth, enough to make engineers feel a bit nervous.
So this is the control room where engineers and scientists are sending commands to the rover and receiving its data back. There's a rather large amount of information to handle.
The test is conducted in real time. Commands are sent to the rover, but it takes hours before it starts moving, the same time it will take for data to travel from Earth to the Mars surface. After many hours of commanding and data analysis, the drill is finally retracted. The sample is then dropped into a drawer, which withdraws and deposits it into a crushing station. The resulting powder is distributed to ovens and containers to perform the scientific analysis on Mars. The rover is a real laboratory on wheels.
It has been a very long testing day. The test has been very successful. We have been able to collect the sample at 1.7 meter. We have been able to take it out, and now the sample has been delivered to the rover for further processing. So we are very happy and very proud of the performances of the rover.
Well, its Earth Twin is being submitted to further test. The real rover, the one that is due to fly to Mars, is carefully stored in an ultra-clean room. The rover is waiting for further pampering in one of the cleanest places on Earth.
Entering that room was no easy task when we visited last year. Strict hygiene measures and layers of protective clothes were, and still are, in place.
Entering a clean room and then an ultra-clean room to see something that's gonna touch the soil of Mars, and feel pretty lucky actually. Let's go.
Welcome to the clean room, the antechamber to the ultra-clean room. Scientists working here only wear one layer of protective clothes and they enjoy a wonderful view over the real rover, carefully stored behind thick glass walls. So all the material that's going to go inside the ultra clean room needs to be thoroughly cleaned, and that's going to take at least an hour. Chemical agents are used to clean the equipment, but anything located inside the ultra clean room itself went through numerous cleaning cycles, including dry heat treatment. Our host Enrico Andrea Nistico is a planetary protection engineer, and as his job title suggests, he's here to make sure we, like all personnel working here, respect the most stringent rules. Protecting other planets from terrestrial contamination is actually a legal obligation under the UN Outer Space Treaty. The buzzing activity we witnessed in that room last year has somehow subdued. The Rosalind Franklin rover is now patiently waiting in its ultra-clean room for some big decisions to come. The road to launch, now planned for 2028, remains long indeed. Europeans need to devise new ways to develop a lander and upgrade all the existing hard and software. There are surely many more exciting episodes to come in the long journey to Mars.
This is SpaceTime. Still to come, understanding neutron star mergers. And later in the science report, we try to answer the question, are dogs left or right-handed? All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, Incogni. If you're anything like me, you're probably concerned about your privacy online. And for good reason. Did you know there are hundreds of data brokers out there quietly collecting, buying and selling your personal information? Now, I'm talking about your phone number, your home address, your browsing habits, even your location history. And that's where Incogni comes in. Incogni is a service that acts on your behalf, requesting the removal of your personal data from these shady data brokers. And they don't just send a one-off email. They follow up, track responses, and ensure that your data actually does get deleted. Think of it as having a digital privacy agency constantly working for you behind the scenes. And the best part, it's all incredibly easy. You just sign up, give them the go-ahead, and Incogni take care of all the rest. And within just a few weeks, you'll start seeing the results. There'll be fewer spam calls, less targeted advertising, and a genuine sense of relief knowing that your private data is no longer being traded like a commodity. Now, as a SpaceTime listener, we're offering you a special discount deal. Just go to incogni.com/StuartGary. That's incogni.com/StuartGary. And if you're not completely satisfied, no worries. Incogni offers a 30-day money-back guarantee, so you can try it out risk-free. You know, protecting your privacy really shouldn't be optional in this digital age. So let Incogni help you by keeping your personal information where it belongs, with you. That's incogni.com/StuartGary to access this exclusive discount offer and learn more. Stay safe, stay private with Incogni. Scientists have used deep learning neural networks to try and better understand the violent events associated with the merger of neutron stars. Neutron stars are the remains of massive stars, more than 8 times the size of our Sun. When they eventually run out of fuel, the balancing act between gravity pulling down and nuclear energy pushing up ends. Gravity wins. The star then begins a violent collapse in on itself, what we call a core collapse supernova. This results in a flash so bright it can outshine an entire galaxy. What remains is one of the densest objects in the universe, a neutron star. In fact, these objects are so dense, just a teaspoon of neutron star matter would weigh billions of tons. And all that mass is crammed into an object no bigger than a city. In fact, other than black holes, neutron stars are the most intriguing objects in the universe, and they're responsible for the manufacture of a lot of the heaviest elements on the periodic table. So understanding what happens when neutron stars merger will go a long way to understanding both the life cycle of stars and the evolution of the universe. The new findings, reported in the journal Physical Review D, have allowed the authors to, for the first time, gain a deeper understanding into element formation in these intense stellar environments. Using a novel simulation model based on machine learning, they've modeled the energy release during rapid neutron capture nuclear synthesis in hydrodynamic simulations. Many of the chemical elements we know today are created in massive stellar events, such as the explosion of stars, supernovae, and for the more massive elements, the merger of neutron stars. These events release incredible amounts of energy, which allow for the production of heavy nuclides. And one key nuclear production process is the so-called rapid neutron capture process, in which free neutrons are captured by existing nuclei and converted into protons, thus creating larger, heavier atomic nuclei. The study's lead author, Oliver Just, from the Facility for Anti-Proton and Ion Research in Darmstadt, Germany, says scientists around the world have strived to try and make these complex reactions understandable through theoretical simulations. However, modelling all parameters requires incredible computing power, which is why most models have needed to be simplified. Just says this new model, called RHINE, which stands for Rapid Neutron Capture Process Heating Implementation in Hydrodynamic Simulations with Neural Networks, hence the term RHINE, uses artificial intelligence and so offers an efficient alternative. RHINE uses machine learning, specifically a neural network based on deep learning, to describe the energy release from the nuclear reactions in a rapid neutron capture process within hydrodynamic simulations of the events. This heating could have significant impacts on the dynamics and velocity distribution of the material ejected by the supernova explosion and on the electromagnetic radiation which, in the case of neutron star mergers, is observed as a kilonova. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. New Phase 3 trials of next-generation diabetes and weight loss drugs known as GLP-3s suggest the once-weekly injection can significantly improve blood sugar levels and lead to substantial weight loss in people with type 2 diabetes. Unlike the current widely used medications, such as Ozempic and Mounjaro, which target the GLP-1 pathway alone, retatrutide, known as GLP-3s, target 3 pathways related to metabolism: GIP, GLP-1, and glucagon. A report in the Lancet Medical Journal investigated the effect of a once-weekly injection of retatrutide on 900 people with type 2 diabetes, comparing the drug with a placebo. After 40 weeks, the blood sugar levels of people receiving the drug had dropped by between 1.7 and 1.9% compared to 0.8% for people receiving the placebo. Participants receiving retatrutide also lost on average about 11.5% to 15.3% of body weight compared to 2.6% for the placebo group. The authors say additional clinical trials and longer-term follow-ups are now underway to confirm retatrutide's safety and effectiveness. For the first time, mighty ocean waves generated in the Southern Ocean near Antarctica have been accurately measured all the way to the tiny ripples they form on the shores of Alaska. The study, reported in the Journal of Geographical Research Oceans, used data from drifting ocean buoys to discover that swirls generated by large storms can travel thousands of kilometres, with longer waves travelling much faster than shorter ones. The authors found that swirls are difficult to measure, but have a significant impact on coastal flooding, beach erosion, ship routing, and the atmosphere. That's because carbon dioxide levels in the environment are also affected by waves. Most people are either left-handed or right-handed, but a new study has found it's harder to tell which handedness dogs are. A report in the Journal of the Royal Society Open Science adapted a test used for measuring human hand dominance to see if they could tell left-pawed dogs from right-pawed dogs and how strongly they held a preference. 47 dogs went through the test, which involved tasks including reaching for food and walking down stairs in various settings. The authors found that paw preference differed depending on the task and often depended on the dog's sex. According to the overall test results, 1 in 5 dogs were fully ambidextrous, 1 in 3 were strongly right or left-pawed, and the rest weakly favoured either right or left paw. Overall, dogs tended to favour their left paws more often, with this trend appearing stronger in males. Well, as we reported the other week on the SpaceTime Science Report, researchers have found a link between consuming omega-3 fatty acid supplements and an associated acceleration in cognitive decline in older adults, potentially through adverse effects on cerebral synapses function. However, other studies have shown clear evidence of the overall benefits of omega-3 fatty acids for things like heart health, significantly reducing inflammation. So that's a balancing act you're going to need to work out for yourself, at least for now. But as the skeptic's Tim Mendham points out, if you do decide to take fish oil supplements, that doesn't mean it's all, or even mostly, omega-3 fatty acids.
Fish oil is supposed to be good for you. It's supposed to be good for your cell structure. It works towards the cell outside layer of it. It's all very good. It became a big thing, the omega-3 sort of craze about, 15, 20 years ago. People say, you should take this pill. It's got fish oil in it. You're not going to get enough fish oil from your ordinary diet, so take this pill. The trouble is, and the example I've seen is a 1,000 milligram pill has about 300 milligrams of fish oil, of omega-3. So you've got to take a lot of pills to get a reasonable amount. And supplement, therefore, there's little evidence that it's going to help you a lot. Fish oil does help you, and the suggestion is go and eat some fish, especially oily fish, which is the sardines and that sort of stuff.
Mackerel,
eat it
salmon,
twice a week.
Sort of thing.
Yeah, eat it twice a week, and you'll get the fish oil you need. Supplements, you have to take a hell of a lot. Someone was saying you have to take about 12 1,000 milligram pills a day for several months to actually get the right effect you're after. They said it's easier. Eat some fish. Omega-3 fish oil does help. I don't know whether it helps as much as people say it helps, but the supplements, you basically got to take a hell of a lot and hope that what's in those pills is actually sort of proper and well tested. So,
and
yes.
Also, there's a shelf life with omega-3 and fish oil tablets.
Yes, yeah, but that's always the case with supplements, etc. The supplement industry is huge, and most of the supplements give you very nice coloured urine. The fish oil has a basis in truth, but there's a lot of sort of extreme claims made for it, and eat some fish.
That's the skeptic's Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.